Hello, everyone. I would like to begin today's event by giving a land acknowledgement on behalf of the school. As a land grant institution, UCLA acknowledges the Gabrielino Tongva peoples as the traditional land caretakers of Tovaangar, the Los Angeles Basin and Southern Channel Islands. We pay our respects to our ancestors, elders, and our relatives and relations, past, present, and emerging. Thank you for joining us today from wherever you are for a very exciting event on water equity. My name is Veronica Santos, the Associate Dean for Equity, Diversity, and Inclusion and Faculty Affairs at UCLA Samueli. Today's webinar is part of UCLA Samueli's Engineering in Action series, designed to promote equity and inclusion through essential dialogues on societal challenges encountered in engineering disciplines. Last year, we held panel discussions on equity in artificial intelligence and transportation. This year, we are launching the series with a conversation centered around equitable access to safe, reliable, and clean water. At UCLA, we believe that diversity is an indispensable element of academic excellence. The UCLA Samueli School of Engineering is committed to providing a more equitable, diverse, inclusive, and nurturing learning environment. We strive to achieve a diverse student and faculty body with programs designed to complement a rigorous engineering education for anyone with the talent and the desire to succeed. Last year, we launched the Mentor Professor Program, recruiting faculty members who are not only excellent in their research, but also have a demonstrated success in mentoring students from underrepresented and underserved populations, and can provide mentorship in research and professional development. We are excited to welcome our first cohort of mentor professors to UCLA Samueli. Sergio Carbajo, Assistant Professor of Electrical and Computer Engineering, who specializes in ultra-fast photon and particle sources. Reagan Patterson, Assistant Professor of Civil and Environmental Engineering, whose research combines sustainability, transportation, and social equity. And Taisha Wright, Assistant Professor of Chemical and Biomolecular Engineering, who specializes in the applications of polymer chemistry, biochemistry, and biophysics in medicine. And in January, Tira Bills, who specializes in the socioeconomic impacts of transportation decisions, will join UCLA as an Assistant Professor of Civil and Environmental Engineering, with a joint appointment in the Luskin School of Public Affairs as part of the university-wide Rising to the Challenge initiative, spearheaded by the Bunch Center, to expand the scope and depth of scholarship that addresses racial equity issues. Before we start the program, I want to thank our partners at the Luskin School of Public Affairs and the Los Angeles Department of Water and Power who brought you this event. I want to especially thank the students from the UCLA chapter of the National Society of Black Engineers for their hard work in launching this series and bringing you today's programming. Thank you, Alexander Johnson and Itohan Ero, for your partnership. Now it is my honor to introduce our distinguished panelists and moderator for this event. Our first panelist, Evelyn Cortez Davis, professional engineer and board certified environmental engineer, is the Director of Water Engineering and Technical Services at the Los Angeles Department of Water and Power, LADWP. Since 1992, she has risen through the ranks, playing different roles at the LADWP. Her team designs and delivers critical water infrastructure projects to bring reliable water service to the 4 million residents of the city of LA. In the next 20 years, she hopes to transform the city's water infrastructure to deliver safe, efficient, local, and recycled water sources. Welcome, Evelyn. Our next panelist, Dr. Shelly Mahendra, is a professor of civil and environmental engineering at UCLA Samueli. She teaches courses and conducts research in the areas of environmental biotechnology and nanotechnology, and has developed innovative technologies for water purification, energy recovery from wastewater treatment, molecular biological tools for monitoring biofilms, and remediation of emerging water contaminants. Welcome, Shelly. Our next panelist, Dr. Gregory Pierce, is co-director of the UCLA Luskin Center for Innovation and co-director of the Water Resources Group at the UCLA Institute of the Environment and Sustainability. His research is motivated by the persistent inequities in access to essential environmental services needed to survive and thrive. He examines infrastructure planning and policy and demonstrates how communities can strategically cope with and overcome inequities with a primary focus on water and security. Welcome, Greg. Last but not least, I want to welcome our moderator, Dr. David Jasby, Associate Professor of Civil and Environmental Engineering and a member of UCLA's Sea Change, winner of the 2021 Livability Challenge. Thank you for moderating today's discussion. Please take it away, David.
Thank you, Dean Santos. What a great introduction. And thank you, everybody, for joining us this evening for what I hope is a very exciting and interesting discussion. So let's just get going, I suppose, without further ado. So this is a question for all the panelists. Can each of you share with us a bit about your current role and what water equity means to you? And let's start with Evelyn, please.
Thank you, David. I'm so excited to be here and talk about the passion of my life, water. My role at LADWP is to take on the challenges of our aging infrastructure in the city of Los Angeles and provide whatever innovative solutions we can, innovative designs, so that we can either expand, improve, or replace that infrastructure and get us to the next level. So we have the ability to transition to local water supplies and meet all of the various regulatory challenges that are facing us every day. And our water system in LA is vast, it's complex, and we've been growing it for the last 100 years under a very, very different set of circumstances than we have today. Over the 100 years, we have grown from a small system of open and covered ditches to over 7,000 miles of underground pipes throughout the city of LA, and 100 pressure zones and more, over 465 square miles. We have a lot of infrastructure to look at. Now, in my role today, I get to challenge my team of 400 engineers, technical professionals, to look holistically at our projects so that we can balance sustainability and innovation with the very real investment in dollars that we're asking our ratepayers to make, because none of this is going to be easy. With respect to water equity, water equity means three things to me, mainly. That every Angelino has access to reliable, high quality water no matter where they live. Two, that the cost of those investments to improve system reliability are borne by all and shared across all our ratepayers and not just a few. And three, that the communities that we serve have access to timely information so that they can know more about their water and have opportunities to engage and to stay informed. I'll leave it there.
Okay, that's really nice. Shelly, how about you?
Hi, thanks, David. My name is Shelly Mahindra. I am trained and wired as a scholar educator in environmental engineering and science. So much of my research has to do with understanding, quality of water, treatment, characterization. What equity means to me is providing the appropriate quality and quantity and information of water to all Angelinos, including non-human members of our environment and ecology. I'll just stop there.
Okay, thank you. Greg.
Yeah, I'll say water equity means to me really the human right to water, and we have a legislated human right to water in California that says every Californian has a right to safe and clean, or high quality, accessible, which I would think sort of better, reliable is a better word, and affordable water. And we work at the Luskin Center really to make that a reality with stakeholders all the way up to the state, to local communities, and do things like, for instance, help the state design its first statewide water affordability program to again make water affordable for all Californians, but really work across reliability, affordability, and quality issues and focus on solutions.
Great, those are all super interesting answers. And it's really interesting that everybody's coming at it from different directions, but we all want the same thing ultimately. That's very encouraging, right? So I'd like to move on to the next question, and this is a question for Evelyn again. You get to start.
Sure.
How does LA's historical water development activities, for example, the building of the LA Aqueduct, or the different salt intrusion barriers, or the changing reliance on groundwater, how do those things impact today's access to clean water for different communities in Los Angeles?
What a great question. How much time do we have? I'll leave it as condensed as I can. So historically, you know, we expanded the original expansion of the city of Los Angeles, the original pueblo. That expansion relied on imported sources of water because our local source at the time was the Los Angeles River, and it was not able to sustain the growth of the city at the time. So after building our original Los Angeles aqueduct, the city made a concerted effort to invest in metropolitan water districts, construction of the Colorado River aqueduct, to start bringing water to Southern California back in early 1940s. Later, to bring water from Northern California through the State Water Project. These sources of purchased imported water have continued to supplement local supplies to meet our growing demands over the years. And our current focus now, of course, is to start reducing the reliance on those imported water purchases and shift to local supplies. And so when we talk about local supplies, we're talking about groundwater. In the past, when imported water has been less reliable, local groundwater in our wells that we have access to throughout the city provided as much as 25% of our supply. So during extended dry periods, this has been really key, but access to that groundwater has been challenging, especially over the recent years because of legacy groundwater contamination that was really not the doing of any of the existing residents of the city or the city itself or DWP. It was really a result of unregulated and improper handling of hazardous chemicals that were disposed of, or handled in either the aircraft manufacturing industry, other industrial activities dating back to the 1940s. So this is a long problem long in the making, and we have a lot of efforts underway now to remediate that contaminated groundwater at our wells so that we can restore access. So that access to that clean water is going to be relying on that remediation effort. And the other local sources that we're talking about, stormwater, recycled water, that's been a challenge as well, because in the past, we've literally built stormwater capture, flood protection, and wastewater facilities with one purpose in mind: to get wastewater and stormwater as quickly and as efficiently, as far away from us as fast as possible. And guess what? We did a really good job of that. And now we're having to reimagine and repurpose some of these historical infrastructure investments to do the opposite, to rely more locally on those supplies and really see them as resource and kind of rethink how we see those supplies. It's important to note when we talk about how our infrastructure has grown here locally and evolved over the last 100 years in LA, and because of how the water distribution system is plumbed today, most areas in the city are served with a combination of various different local and imported supplies. And no matter where you are in the city, we're supposed to have all of this safety requirements met. So we're working around the clock to do that. And access to clean water is meant to be consistent across all areas of the city. But we know there are problems, and that's what we're here to solve. So
very simple. Thank you. And it's as a professor in environmental engineering, encouraging to me to hear that there's so many job opportunities for the students. There's a lot of work to be done.
There's a ton of work.
That's great. Thank you. So the next question is for Shelley and for Greg. Shelley, maybe you start. How does the existing water infrastructure impact communities differently across Southern California?
Yes, we are all residents. It's a big Los Angeles or Southern California, the big city, and divided into various administrative units. I can't always keep track of, LADWP plus, 80 or so associated water utilities, and the source waters are different. The infrastructure is varies as over time the city developed and various neighborhoods. Some of the neighborhoods were able to put in improvements and repairs in the infrastructures. The others had various other challenges, technical or otherwise. The current infrastructure, let's be honest, a few years ago, almost 10 years ago, American Society of Civil Engineers graded our nation's infrastructure, including our local infrastructure, and I believe the average grade was D+. And that's a grade that no students applying to or graduating from UCLA has seen. So it's distressing, but we look at it as an opportunity to pool our resources. There's innovations that are happening in the academic as well as industry practitioners that are addressing these questions. Environmental science and engineering is surprisingly, I would say, more than many other disciplines, open to diversity of individuals, the workforce, as well as benefits from various other related or even far-fetched disciplines, whether it's material science, whether it's chemistry, chemical engineering, biology, microbiology, public health, a variety of different things. So we do have that opportunity to bring in all that diverse expertise combined with investments at the local, municipal, state, and federal level to build in that infrastructure. But, first step is to recognize and characterize the problem, and their active areas of inquiry, and those are being addressed at different levels. So more than technical regions, and I'll stop because this is primarily Greg's area, but depends on our location and depends on the age of our neighborhood or age of the residential or business dwelling that we live in, the infrastructure that brings in water from the treatment plant to our street, but then within our building, what comes out of the faucet, the premise plumbing is also old and new and different materials and different quality. So there's several challenges, but they are beginning to be recognized.
Great, thank you. Greg, you want to take it away?
Yeah, and I could talk about this all day, but I think the first thing I really want to emphasize is that although LADWP is by far the largest water system we have in the region, and the most important because it serves the most people, and doing a lot of progressive things, we have 200 water systems in LA County that serve residents like you and me and small businesses. Each of them, they range literally from a mobile home park that serves 25 people to LADWP, which serves 4 million people. If you widen the lens out to Southern California, we're talking the 20 million people in Southern California, we're talking about 500 systems. Each of them really are responsible for that human right to water, making water high quality, affordable, and accessible. But they have very different capacities, capabilities, and sometimes interest in really delivering on that. And we do see really big inequalities, especially with regard to reliability and quality. And although I would say quite common challenges with respect to affordability, whether you're a large or small system. And then the other thing that Shelley mentioned that I just want to amplify is that when it comes to the water coming out of your tap, a lot of the quality there, or at least what you may perceive as the quality, is really going to be impacted by the pipes in the building you're in, whether it's a home or a school or a private business. And there's really not a great sort of regulatory structure and way to fix problems where those arise. So that's sort of a frontier of inequality that especially is cropping up in very core urban areas, including LADWP territory.
Great, thank you. So we're going to segue a little bit into this next question. And Greg, I'd like you to provide a policy perspective for this particular aspect of the question. What are the factors influencing equitable access to clean, safe, and reliable water? And you already started to touch on this.
Yeah, so I'm going to sound like a broken record in so much as, again, the California sort of framework is around quality, and it's around affordability, and it's around what's called accessibility, but I think reliability is a better term. Quality is regulated nationally under the Safe Drinking Water Act, and there's some variations and permutations, but essentially, again, every system that serves folks, it has to meet the standards at a national level. We actually do better, I do want to emphasize, in LA County on quality than a lot of other places, even in California, but we also face some profound challenges, especially with sort of emerging contaminants. Affordability is relatively a new focus and has gotten a lot more attention just in the last decade, but I think will be more and more of a challenge, especially as we make transition toward local water. And frankly, the cost of water in general is rising, has to rise for sort of the average customer. It's really about how to shield lower income or vulnerable customers from those impacts. And I think we are actually seeing, a range of policies taking place from the federal level on down, but they're all very recent, including prohibition on shutoffs. And then reliability is actually, even though we're in a drought, we're seeing water systems run out of water, although more so in Northern California than Southern California. There's not actually a clear sort of household level or customer level framework for how to address those issues. So that's something we have a lot more work to do, as we anticipate this drought continuing and future droughts.
Great, thank you. Shelley, can you provide some technical focused opinion on this? How can we, yeah, go ahead, sorry.
If I understand your question correct, it's about the current stage, right? We tend to talk about in the future, and of course that is important, but I understand that discussion is coming in a few minutes. So yes, depending on who you are, where you live, whether you own or rent or are directly paying your water bill, or it's through a landlord or a homeowner association or a business or school, the quality of water and reliability of water, and like Greg said, affordability of water varies. And as much as we absolutely recognize and agree with water as a human right, but it's also a commercial product. So there are costs associated with it. And sometimes they are directly related to the inputs of resources. The more important thing with respect to the quality of water depends on the source of water. So there are areas, I like to say that we here in Southern California, we have plenty of water to the west of us, but then that's not drinkable. But there are ways to make it, desalination and others, to make it drinkable or at least used for some other non-potable uses. There's plenty of water under our feet, and that also has historically been contaminated by industrial inputs, by treated wastewater injections to prevent seawater intrusion, and agricultural and variety of other pollutants. And some technologies exist to remove those things in water that are undesirable, but there's plenty of more research and scale up and technology and application. So much of our industry is grandfathered. It's hard to tear down water infrastructure and put in a new plant every few decades. There is really good water to the east of us, but it has other challenges. I'm going to speak to the technical ones. One of them being it's on the other side of the San Andreas Fault. So there cannot be a bigger incentive for us to invest in securing and reliable locally produced water of the appropriate quality, which could mean drinking water quality, which could mean other non-drinking uses within our built environment, but also recreational and ecological services that water and our ecosystems provide. So those are some of the technological factors that influence the kind of water, the quality of water that exists, but they are addressable, and there seems to be technology and will to address them.
Thank you. So Evelyn, we've heard from both Greg and Shelley about the cost of these, the future of water. Can you give us a little more detail on that?
Yeah, so just one example I had brought up a little earlier about this legacy contamination, and Shelley was mentioning this as well. This is pervasive. There isn't really any pristine groundwater source or aquifer that we have access to or rights to locally here. At some level, there's some level of contamination that needs to be addressed when we pump groundwater, or at least to treat the water in some way and disinfect it in order to be able to serve it. In the areas where the contamination is prevalent, and in particular the San Fernando groundwater basin here in the city of LA, that is where we have the majority of the groundwater rights to the city of LA, where we have access to a number of different well fields. More than about 2/3 of our groundwater wells have actually we've had to reduce or eliminate pumping from them because of contamination intrusion into those wells. And so the access that we have right now to pumping is very, very limited. So expanding or restoring access to that resource is actually requiring a significant investment of dollars. That's what we're talking about, where costs really crosses over. We're talking about $500 million of investment of ratepayer dollars over the next few years, where we are going to eventually and aggressively seek out reimbursements from the potentially responsible parties that are responsible for the pollution in the first place. But legal action, as everybody knows, takes long periods of time. We do not have that time to wait anymore in order to make that resource accessible again to the city of LA. And so we've had to make that decision to proactively remediate the groundwater and then go after all of the funding sources that are possibly available to us under the sun to be able to restore that resource as soon as we can. But the cost the costs are real. Again, none of this is going to be free. At some point, we have to really come to terms with how does the investment of the transformation to local water supply impact our ratepayers, and we have to take those things into account as we go.
Okay, great. Some large numbers you're talking about over there, but I guess it's infrastructure, right? And
That's what it costs.
That's what it costs. It's expensive. It's expensive business. Okay, great. So here's a question for the entire panel. Anybody can pick it up. How does representation and leadership affect water quality and water policy in different communities? Anyone?
I can start with that one if you want. So I've been thinking about how the way that our leadership approaches communicating and engaging with the communities that we're trying to function within is really critical. And the way that the community is able to relate and communicate back to us, so we're reaching into the community and communicating appropriately, is really critical. And so when the community can see themselves in the leadership, can actually see themselves represented, that makes a big difference in how their input, how their comments, how their concerns are being addressed, or whether they perceive that they are not being addressed. So for example, we have some infrastructure projects that are located in very specific areas of the city that is strictly due to the hydrogeology of the location, because our ability to either infiltrate or extract groundwater, infiltrate stormwater or extract groundwater. And these are the types of projects we're after. And then that's not necessarily something that's intuitive to a member of the community who may feel like we're overlapping all of these projects on top of them and thinking that there's another reason or a different reason for that. And we really have to be proactive in the way that we communicate. How that information is received, I think, really does depend on whether the community is open to receive the information, and being able to see themselves represented in that leadership, I think, really does make a difference.
Yeah, it sounds like community engagement is going to be absolutely critical moving
Yes.
forward, particularly when we're talking about these very large investments that can be quite disruptive to the locals' lives too. Lots of constructions, trucks, nobody likes that. Got to be able to talk to everybody.
That's right.
Anybody else want to take this up?
I would just emphasize everything. I agree with Evelyn, and would say yes, representation as well as communication at various levels, and a perceived transparency is important. Because most people, including us, we like, I'm paying $70 for my water bill. Where is it going?
That's
Good
right.
point. So Greg, what does this community engagement look like?
Yeah, I think really building off what others have said, first of all, it looks like having it, I mean, there's levels of it, I would say. The first is providing information. And we found when we reviewed the 200 water systems in LA just last year, for instance, 50 of them didn't have their own websites. So starting there. The second, I think, is though not just volume of information, but really, well communicated, targeted information, because some of these topics get very technical quickly, and we can't and shouldn't expect, even maybe others on the panelists who are experts in a certain area to be able to, much less the average person, to really want to or have the time to get into really technical detail, but to really think about communications and things like the water quality reports, I know a lot of utilities are rethinking how they communicate there. And then, third, I think what Evelyn's saying, representation in decision making really facilitates genuine community engagement and community interest in engaging. But then I think when it comes to community engagement, we also have to think even more about compensating community members for their time, not just engaging, but really making sure that their feedback is incorporated and that they see that. And again, not just expecting that folks want to be engaged and can sort of treat water system engagement as a part-time job without compensation. So really looking to give target information, seek key feedback, and also show how that feedback is valued, I think are some of the steps that need to and are beginning to be taken by certain water systems, but we also need to see more.
Great, excellent points. So this is a question that I find particularly interesting because it's kind of related to my research and things that I'm personally interested in. So how is the landscape of available water resources changing in response to emerging technologies and contaminants and social acceptance and concerns? And Shelley, why don't you start off here since you're our resident technical expert?
Yes, we have water resources. They may not be, appropriately distributed in terms of quantity and quality and just reliability. With respect to emerging technologies, there's definitely, I'm an optimist in this case. We're talking about water and glass, so I always see the glass full, not even half full, half full of water and half full of air, and air is important part of the environment. So yes, there are emerging technologies that have the potential to make a big difference in terms of preventing leakage and losses and improving the quality, improving the delivery, real-time sensing of the quality, predicting any failures in the pipelines or contamination. There are technologies that characterize and quantify contaminants, legacy contaminants, as well as emerging contaminants that would allow us to make real-time decisions between, providing alternate water sources or informing the public, and any changes that might need to be made on the fly, increasing communication and, water resources with respect to social acceptance of indirect or direct potable reuse in characterization of contaminants. Much more responsibility of the utilities in not only bringing water to our doorstep, but maybe for a transition time, being invested in maintaining premise plumbing that came up earlier. So the piping inside the buildings, in our homes, in our businesses, in our schools, other places. And I do think that available water resources will fluctuate, but I think we are moving towards decentralization a little more and decarbonization of our water sources and water infrastructure.
That's great. So Evelyn, maybe you can discuss, in the context of this question, how does the State Water Project and our drive towards local resilience, how do those two aspects intersect with the available water resources and emerging technologies?
This is such an important question. Every 5 years, we're actually required to put together an urban water management plan for the city that actually outlines everything about, with a 25-year horizon, what do we expect our water demands to be and how do we expect to meet them, whether it's an extended dry period or normal conditions. And the truth of the matter is that no matter how locally reliant we become, there's always going to be a component of imported water in our water portfolio. There needs to be, because we have a severe swing now in extremes. We used to be able to plan differently. We used to be able to predict a little bit better when we were going to hit. The 100-year storm is no longer the 100-year storm. We're seeing them with a lot more frequency, with a lot more severity. The extended drought periods are even more extended now. So we're having to plan differently now. And so that although we're trying to be less reliant on imported water, we, I think, have to move forward with a solid investment in those imported supplies so that they are there when or if we need them. At the same time, we have, like we heard mentioned earlier, we're an earthquake country. So we are making very real investment as well in an earthquake resilient network of pipes within the city, so that when or if we are cut off, we're able to actually access those local supplies and deliver it within the city's boundary. But this also takes a long time to transform, because we're talking about, you know, a significant amount of infrastructure that's under the city streets.
Thank you. Can maybe somebody comment a little bit of how and Evelyn, you've mentioned this already with stormwater capture, but maybe for the audience to touch on how climate change and the expected changes in precipitation patterns are going to impact the water resource availability in Southern California.
If I may just jump in on this one really quick, because I know the question comes up a lot. We get questions in the community a lot whenever we have a rainstorm. Why can't you just capture all of this water right now? What's going on? Why aren't you doing your job? And the reality is that we have in the Southern California area, we have out of every 10 years, roughly 7 years are dry. And we get the majority of our precipitation in a 3-year period, and we don't know when those are coming. The reality is that we're getting larger amounts of precipitation in a shorter windows of time. So the capacity that we have to build is enormous. And that investment is not necessarily, it's cost prohibitive. Once we really put that into terms that the community can understand, it's a little easier to have the conversation. We actually developed a stormwater capture master plan that talks about this and why developing stormwater capture capacity is important, but it's also not feasible to design for that intense storm every time.
So just for the audience and for everybody who's, might be interested, what are we talking about? What kind of volumes are we talking about? And how much is it going to cost to capture, inject, store? What are our options?
So the stormwater capture master plan has, our goal is to be able to capture about 49 billion gallons of water per year by the year 2035. By the year 2035, this means improvements in our groundwater spreading basins, so the stormwater basins that we have in the valley and other locations, and also investments in upstream county operated stormwater capture facilities that then deliver the water to local groundwater for infiltration within local basins. So we have some major investments that we're in the process of building right now, right in the San Fernando Valley. That is where, again, the hydrogeology allows us to do that, the infiltration and extraction. But we're talking about a significant amount of dollars. This is, we're talking about expanding the stormwater capture capacity enough to be able to supply somewhere in the vicinity of 48,000 homes water supply. It's significant. We want to be able to invest in this, and this is local, but not necessarily as predictable as we would like it to be. Sometimes it does rain in LA. We just need to, we need the capacity to capture as much of it when it does come.
Interesting. Thank you so much. That was really interesting. So now, Greg, do you want to add anything about the landscape of available water resources, or and how it's changing with respect to technologies or contaminants, social acceptance and concerns? Perhaps you can touch on that.
The social acceptance and concerns. I mean, I think we are seeing, as opposed to a few decades ago, much widespread conservation ethic, although we have more to do in the current drought. We're not doing as well as we did in the drought 5 years ago, so there's further to go there, but I think there is growing acceptance that we need to use less water, and growing acceptance also around something we didn't message well in the past, which is recycled water. And we're seeing, acceptance and really willingness to support the enhanced stormwater investments that Evelyn's was talking about, in so much as in LA County, we passed a tax on ourselves just a few years ago to put $300 million a year into a county program to invest more in stormwater. So I think we're heading in the right direction. I still have questions about whether we're heading quite fast enough, but I do think the larger water systems and sort of agencies are moving toward more diversified sources and sort of decentralization. Where I still have concerns is around the very local systems that are certainly decentralized, but aren't diversified, aren't really tied into these larger investments, whether it's desal, recycled, stormwater, and also don't and have never had really fully trained operators, certainly not operators who could toggle between different water sources. So I think we have more work to do there.
Okay, thank you. Okay, our last question. It's for all the panelists. Anybody can jump in. So what actions can we take as an institution? For example, interdisciplinary or multidisciplinary steps where we can make an effect change in our environment. Shelley, you want to take that since you're a bona fide professor?
I'll start. And like I said earlier, it is our responsibility to research innovative ways in which we characterize the water quantity and water quality, and also research ways in improving the infrastructure and the quality of water. So innovative ways in which we can provide the water quality, just fundamental science. So it is most important to have solid science. And as our role as educators, not only serve as transmitters of knowledge, but have a conversation with respect to proactively predicting the challenges and probably developing solutions for example, emerging contaminants before they get out of control. And doing it together in a way that combines the best of our foundation in STEM, but also incorporate the related disciplines and the powers of our left and right brain and collaborative colleagues that we have across campus to really look forward and provide the best research and education together. And in addition to our role as in research, teaching, we also have a responsibility for professional and community service as part of our charge as UCLA professors, and do the best we can in our capability to engage with local community and provide proactive responses and service and support.
Thank you. Evelyn, what do you think as, representative for the government? What's your take on this?
So I have one global call to action here: engage, because we all have the power to do this. Whatever engagement looks like to you, whether it's contacting your elected officials in support of water projects, local water supplies. We have Congress and President Biden in the process of enacting an infrastructure bill that's going to have a significant number of dollars investment into water reliability, varying areas of our water infrastructure. And we have the list of projects that we are in the process right now of queuing up in terms of priority of where we want to go. Once the opportunities come, I think that the elected officials are going to look to their community members and their stakeholders out there in the world to know whether they are supportive of what we're moving forward with. And I think that the bottom line, and when elected leaders are knowledgeable and engaged in water issues, everybody wins. So if we have our environmental engineers, our professors, our local institutions, our students, everyone who is knowledgeable about water or is interested in and enthusiastic about water, contacting those elected officials and having them engage with experts, with institutions like UCLA and the various schools and the industry, the utilities like LADWP and the many other water systems out there, I think everybody wins. And so if somebody's out there wondering how to engage, I'll give you a website right now, ladwp.com, Water Strong. That is where our local plan for switching or transforming our infrastructure to local water supplies. You can read more about that and figure out where your piece is, because we're going to have a lot of opportunities and need for community input on this. There are lots of opportunities to engage. There's a transformation coming to recycled water that's called Operation Next. You're going to hear a lot more about it over the coming years. Significant investments and a lot of opportunities to engage.
Great, thank you. That's a great resource. I appreciate it. Sure, everybody on this meeting will also hopefully look at it. Greg, any final words?
Yeah, I would just say also, I mean, I think things other people have said, engage elected leaders, vote, and I'm not saying how to vote, but, make sure that elected leaders and appointed leaders take account of community concerns around water, prioritize them. But I think also conversations like this and really making sure that not just that we say that we're doing interdisciplinary work, but that engineers, social scientists, and public health folks work with communities on solutions instead of being siloed is important. Conversations like this can help. And then, what everyone's been saying, and I'm speaking to myself as much as anyone, but make sure that the communication we try to convey is interesting, and also recognize that it is quite interesting and we have ways of making it interesting, but we need to work on that and make sure that people are sort of vested in water and realize how important it is to the region, how it relates to our history, and really to social concerns more broadly.
Thank you. Everybody, thank you very much. That was a great discussion. So we're done with our pre-cooked questions. And what I'd like to do now is to open it up to the floor. And we have a first question from the audience. So let's see. First question is, what research questions should someone who wants to explore equity in water be asking? That's a good question. Who wants to take it? Shelley, you're the only one with that's not muted, so you're it. I can read just basically what research questions should someone who wants to explore equity in water be asking?
Yeah, basically all the research questions will begin as assessment of current situation, what's working, what's not working. And in terms of research questions, they could be at the intersection of both, the science, the technology, the policy, everything. Ultimately, I would say you can't produce water without consuming energy. You can't produce energy without consuming water. You can't produce food without both of them. And then water is critical for health. The roots of our discipline, environmental engineering, are founded in public health. So the questions would be how various multi-pronged questions of where, I guess, technologically what we can do, policy-wise what we can do to provide equity. Yeah, I'm hesitating from being very specific because it's either specific or a comprehensive answer. But yeah, I'll stop with that. Do the best you can. Ask the question which excites you and which incorporates your interests and skills.
Great advice. Evelyn, you want to have something to say? I see you unmuted yourself, so you're ready to go.
I was looking at question 2.
Okay, hold your horses.
So
go ahead.
In terms of research questions, I can tell you that a lot of the solutions that we're looking at, for example, the switch to recycled water and locally available supplies, we do have a lot of investment in a number of research studies right now, because we do not want to take for granted that social acceptance piece. We can have a perfectly innovative, technically viable, cost affordable, reachable project that if it is not publicly accepted, we're not going to get there. So when we talk about real-time monitoring technologies, for example, How does that look for a project that will ultimately allow us to use more recycled water throughout the city and make local reliability more, widely more prevalent throughout the system. No matter where you are, the one project will increase reliability system-wide. So I think that when we talk about water equity, there's a lot of, like we've been talking about, there's a lot of different components. You have technical, you have policy, you have infrastructure, you have funding, you have all of these various different components. And I think I will definitely agree with Shelley. You've got to go with your passion and see if any of those areas, there are definitely pending questions that we're looking at in order to proceed.
Great, thank you. Greg, you have anything?
Yeah, sure. I'll just give 2 questions, and I think we need answers from engineering. We need them from sort of communication studies. We need them from policy. And they're, how can we make water more reliable, but also still affordable? How can we make water high enough quality or ward off quality threats and also make it affordable? There are, right now, in what we're seeing, a lot of decisions, there's trade-offs between reliability and affordability and between quality and affordability. So we need answers that sort of fit all 3, again, if we're concerned about equity.
Okay, great, thank you, good advice. Okay, let's move on to question 2. I know everyone really wants to do this, so we're gonna let her answer it.
I gave it away. I was just itching to answer number 2.
Here, let me read it first though, because I don't think the audience.
No, that's fine.
Can you discuss environmental impacts and permitting issues that can be roadblocks to some of the solutions discussed?
Yeah, so I'm specifically thinking about potable reuse. And Shelley and Greg both mentioned this. This is really this is our next big step. This is our next big investment as a city. We call it our 3rd aqueduct because that's the level of investment that we're thinking about, that we're moving towards. And
before you continue, can you just give like a 30-second explanation of what we're actually talking about?
Absolutely.
Yeah.
Absolutely. What we're talking about is maximizing the amount of recycled water that can be used for potable purposes out of the Hyperion wastewater reclamation plant near LAX. We're talking about a transformation that is it's foundational to what we do, because right now we have over 200 million gallons of water every single day flowing to the ocean. We have a lot of investment in that water. We have a lot of energy that we put into cleaning that water enough to be dischargeable. We wanted to make the extra investment to make it reusable to the maximum extent possible.
So again, what are the environmental impacts and permitting issues that can sort of present roadblocks?
Yeah, so we have an ongoing conversation as an industry with our regulators and our public health officials, because nothing moves forward without the rules of the game. Right now, we have a lot of pilot studies and demonstration programs that are happening throughout the state, and a number of cities and utilities that are moving forward with similar potable reuse types of projects. The Metropolitan Water District and LADWP have put together proposals for some of the largest potable reuse projects, but we do not have a regulatory framework yet from the State Water Resources Control Board. So the Division of Drinking Water is still in the process of developing the regulations that we will need to meet when we put these projects and programs together. Basically, we're moving forward without the rule book and working with the regulators as we go, so that we can at least ask the right questions at the right time, so that the regulations get developed with the benefit of the sanity check from the folks that are going to implement it.
That's really interesting and exciting to be on such a cutting edge of really water production in the world.
Absolutely.
It's an enviable place to be. In some ways, it's also very daunting, right? It's a real adventure.
We're open to and welcome the opportunity, because we are talking about transforming the way we're going to view water and use water in Los Angeles for the next 100 years. That's what we're talking about.
Okay, so let's, if it's okay with everybody, I'd like to move to question 3, because it's a very important question, and we're almost out of time. So question 3, since there are so many smaller water systems serving disadvantaged communities, and they have more limited technical, financial, and management capacity than the larger systems, what can be done to improve their capacity? do the largest systems have a responsibility to help the smaller systems? Greg, you want to take that?
Yeah, I think there's two answers, and one of them was given in the question. From my perspective, is that we need sort of greater view around, or sort of responsibility taken by the larger systems and agencies that are capable of particularly diversifying or providing backup supply, interconnections, technical expertise to smaller systems, and allow smaller systems to operate. I mean, another solution that the state has been promoting, and that is being promoted at the national level, and I will say the fragmentation of water systems is not unique to LA. It's worse across California. It's worse across the US, is actually consolidating water systems. And some of the roadblocks to that, though, actually relate to the last question around permitting and how we can get these types of even small scale projects connecting 200 people to a larger water system done in less than a decade and for less than $10 million. And a lot of that does relate to permitting and jurisdictional questions, but I think consolidation, as well as sort of regionalization and assistance without consolidation, are the two answers going forward.
Great. Evelyn, you have something to add?
I was really just agreeing
Okay.
with Greg.
Great. Well, everybody, thank you very much. We are officially out of time. So some closing remarks. I want to thank everybody for sharing your insightful comments and perspectives. I'd like to thank the audience for paying attention, hopefully. Hopefully everybody learned something new today, and for providing the very insightful questions. I certainly learned a lot from this conversation, which was very fun. After hearing from our panelists, I hope that everybody here is as excited and optimistic as I am on the work we can do together to protect the human right to water. Thank you to our wonderful panelists and all our collaborators who contributed to the event, Dean Santos and the entire team that set this whole thing up. Really appreciate it. You did a great job. Please be on the lookout for more to come in the Engineering in Action series. And until next time, good night.